Lúc đắm đuối tình mình thấy như ánh trăng rằm. Da 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 da. Cho đôi anh tình đã xa. Why sorrows? Lúc đắm đuối thì mình tựa như ánh trăng rằm. Lúc đắm đuối tình mình tựa như ánh trăng rằm. I think we can continue to the oh monsters thing. We need to disable, right? Priorities, listen, push, and if I increase this one, lots of noise. And is this good? Hello. -3 decibels. Android's architecture, and this is I don't know how, but as I remember, the title of this page is Android architecture. But today, when even yesterday, I checked the title and I see the platform architecture. I don't know about this change. Flat update, right? I don't know. Anyway. Now I will use GPT to help me uh, with improves my knowledge, also improves my platform. My hello.
That's great to hear. What specific areas are you looking to improve or learn more about?
Yes, I want to learn more about the platform architecture, just a platforming Android architecture.
Sure. Android platform architecture consists of several layers, each serving a specific.
Excuse me, can I explain to you my knowledge and you can correct me if I'm wrong? Hello?
Absolutely. Go ahead and explain what you know, and I'll help you with any corrections or additional information. Yes, of course. Please share your knowledge, and I'll help you with any corrections or additional information.
Android architecture have several layers. The first layer is Linux kernel, and in this layer we have the drivers or threading or low levels memory management, and we also have is
That's correct. The Linux kernel is the foundation of the Android architecture. It includes drivers for hardware components, manages threading, and handles low-level memory management. It's responsible for basic system functions and ensures that the hardware and software can communicate effectively.
the other layers is hardware abstraction layer. We can call it HORN, and HORN provides standard interface that explore device hardware capability to the higher level. For example, the Java API framework, and the HORN consists of multiple libraries module, and each module will implement as interface to specific type of hardware component, such as the camera or Bluetooth module, Once a framework API makes a call to a set device hardware, the Android system loads the library module for that hardware component. Is that correct?
You've got the right idea, but let's clarify a bit. The correct term is HAL, which stands for Hardware Abstraction Layer, not HON. The HAL provides standard interfaces that expose device hardware capabilities to higher levels like the Java API framework. It consists of multiple library modules, each with interfaces for specific hardware components, such as the camera or Bluetooth. When a framework API makes a call to hardware, the Android system uses the HAL to load the appropriate library module for that component.
We have Android runtime. This is look like a Java virtual machine, and this layer have a Java framework can run on the device.
Yes, the Android runtime ART is indeed similar to a Java virtual machine. This layer includes the core libraries that provide most of the functionality available in the Java programming language. It also includes the ART and, in older versions of Android, the Dalvik virtual machine. These runtime environments execute the bytecode generated from Java source code, allowing Java applications to run on Android devices.
The other layers in native C++ libraries. Many core Android system components and services, such as ART and HARS, are built from native code that require native libraries written in C and C++. The Android platform provides Java Framework API to explore the functionality of some of the native library to apps. For example, you can access OpenGL through the Android frameworks. Uh, for if you are developing
You're mostly correct. Native libraries in Android are indeed written in C and C++ and provide core functionalities for many system components and services, including the Android runtime ART and the hardware abstraction layer HAL. These libraries offer powerful capabilities, and the Android framework provides APIs to access their functionalities. For example, developers can use OpenGL ES for graphics rendering through these framework APIs. However, spell form should be platform.
We have a layer called Java API framework. Most of the Java service will run in this layer, and in this layer we also have a manager that is a library for the app. We explore API to the application layer.
Yes, that's right. The Java API framework layer is where most of the core Java services run. It includes managers and libraries that provide essential services to applications, such as the Activity Manager, Resource Manager, and Notification Manager. This layer exports APIs to the application layer, enabling app developers to interact with the underlying system components and manage app behavior.
The final layer is application, and in this layer we have a system app or third-party app. This is basically the application, and to application to contact with the underlayer, they will use API that were explored by framework.
You're almost there. The final layer is indeed the application layer. This layer includes both system apps, like the phone dialer and messaging apps, and user-installed apps. These applications interact with the underlying layers through the APIs provided by the Java API framework. Essentially, apps use these APIs to access system services and hardware features, allowing them to function and provide a seamless user experience.
So we are develop a automotive platform. So for example, in the hardware abstraction layer, we have a layer called vehicle hardware abstraction layer. That layer extension from the hardware abstract layer. In that layer, we will explore the. That means we will connect the software with the hardware. For example, we need some properties that only run in the car, in the vehicle. So that in the vehicle hardware abstraction layers. Is that correct?
Yes, you're on the right track. The Vehicle Hardware Abstraction Layer, VHAL, is indeed an extension of the hardware abstraction layer, tailored specifically for automotive environments. It allows software to interface with vehicle-specific hardware and sensors, providing access to properties and functionalities relevant to vehicles, such as GPS location, vehicle speed, or sensors for detecting road conditions. This customization ensures that the software running on an automotive platform can effectively communicate and utilize the unique features of vehicles.
So, as you mentioned, in the vehicle we have some specific like GPS, GPS or vehicle speak, and to contact with this ECU, do we need to change in the Linux kernel layers?
No, you typically wouldn't need to change anything in the Linux kernel layer to communicate with vehicle-specific ECUs, electronic control units like ZBS, zero-based budgeting system, or vehicle spec. The Linux kernel provides basic system functions and hardware abstraction, which are generally sufficient for interfacing with different hardware components, including vehicle ECUs. Instead, the customization and communication with vehicle-specific ECUs like ZBS or vehicle spec would primarily involve implementing appropriate drivers and interfaces in the hardware abstraction layer L or vehicle hardware abstraction layer VHAL, developing specific libraries and APIs in the Android runtime or Java API framework to interact with these ECUs, designing applications in the application layer that utilize these APIs to access and control vehicle-specific functionalities. This approach allows Android-based platforms to effectively integrate and utilize vehicle-specific hardware and services without needing modifications to the Linux kernel itself.
For example, I have a sensor and that sensor connect to my ECU, and now I want to our device, that means my Android device connect with my ECU and use the value from my sensor. So as you mentioned before, we need to train in the hardware abstraction layer only, not in the Linux kernel. I'm just concerned about it. I think we also need to train in the Linux kernel, because if we don't update the driver, uh, basically Linux kernel cannot uh, connect to my ECU. Is that right?
You're correct that ensuring proper communication between your Android device and the ECU, electronic control unit, for your sensor involves more than just the hardware abstraction layer, AL, or vehicle hardware abstraction layer, VHAL. Here's how it typically works. 1. Linux kernel. The Linux kernel provides basic support for hardware interaction, including managing drivers and devices. If your sensor or ECU requires specific drivers that are not already supported by the kernel, you may need to modify or add these drivers to the Linux kernel. 2. Hardware abstraction layer, or VHAL. Once the Linux kernel has the necessary drivers, the HAL or VHAL layer provides standardized interfaces for Android to access these hardware components. This layer abstracts the hardware details and provides APIs that Android applications can use to communicate with the sensor or ECU. 3. Application layer. Applications running on Android can then utilize the HAL APIs to interact with the sensor or ECU, retrieve data, and perform actions based on that data. Updating or modifying drivers in the Linux kernel is crucial if the default kernel does not support the specific hardware interfaces required by your sensor or ECU. This ensures that the Linux kernel can properly with and manage these devices, enabling higher layers like the HAL and application layer to function correctly. Therefore, while most of the development and customization for Android automotive platforms may occur in the HAL and above, ensuring kernel level support through appropriate drivers is essential for hardware compatibility and functionality.
So, if you mean if the Linux kernel is not supposed to connect with my ECU, that means I need to update the driver in Linux kernel, as in vice the the Linux kernel already support my ECU. That means we don't need to change anything in Linux kernel. Is that correct?
Yes, that's correct. If the Linux kernel already supports your ECU, electronic control unit, including the necessary drivers for communication, then you typically wouldn't need to make any changes to the Linux kernel itself. The Linux kernel provides the foundational support for hardware interaction, including managing drivers, so having native support for your ECU means it can communicate effectively with your Android device without requiring kernel modifications. In such cases, you can focus on developing the necessary interfaces and libraries in the hardware abstraction layer, or vehicle hardware abstraction layer, VHAL, to integrate the ECU's functionalities with the Android platform. The HAL or VHAL will abstract the hardware details and provide APIs for Android applications to access and use the ECU's capabilities. This approach ensures efficient communication and utilization of the ECU's features within the Android ecosystem, leveraging the existing kernel support provided by Vibus or other compatible configurations.
Here's in my question. Why do we need a native C++ library in our system? Because it's just because the biggest reason is the libraries is only support by using
Native C and C++ libraries are essential in an Android system for several reasons. One, performance. C and C++ are low-level languages that offer high performance and efficiency, making them suitable for tasks that require quick execution and minimal resource consumption. This is crucial for system-level operations and performance-sensitive applications like graphics rendering, multimedia processing, and real-time operations. 2. Access to native APIs. Many hardware components and system services are accessed through native APIs written in C or C++. These libraries provide direct access to hardware functionalities, e.g., camera, audio, and system services, e.g., SQLite database, that may not be fully exposed through higher-level Java APIs. 3. Legacy code and libraries. Existing libraries and codebases may already be written in C or C++, particularly in domains like multimedia, gaming, and system utilities. Integrating these libraries into an Android application allows reuse of existing code and leverages years of optimization and development. 4. System-level programming. Certain tasks require system-level programming that is more easily and efficiently done in C or C++. For example, device drivers, low-level networking, and interfacing with specialized hardware often require direct memory manipulation and hardware control, tasks that are well suited to these languages. 5. Portability. C and C++ are widely supported and portable across different platforms and architectures. This allows developers to write code that can run efficiently on a variety of devices, from smartphones to embedded systems. In summary, native C and C++ libraries provide performance, access to low-level APIs, support for legacy code, and flexibility for system-level programming in Android, enhancing the platform's capability and versatility.
Okay, as I know, the in native C++ library, we have some service. It seems simply talking, we have some service C++ service run on Android, right?
Yes, in a native C++ library, you can indeed encapsulate services or functionality that are written in C++ and can be accessed by applications or other parts of the system. These services typically involve functionalities that require low-level access, high performance, or integration with existing C++ code bases. For example, 1. Media processing. Libraries for audio-video codecs, image processing, and rendering can be implemented in native C++ for efficiency and performance reasons. 2. Game engines. Many game engines are implemented in C++ to leverage performance benefits and direct hardware access for graphics rendering, physics simulations, and game logic. 3. Data processing. Libraries for data analytics, machine learning, or real-time processing tasks may utilize C++ for its speed and memory management capabilities. 4. System utilities. Tools or utilities that interact closely with the operating system, manage system resources, or perform low-level operations may be implemented in C++ for better control and efficiency. These services are packaged into C++ libraries, which can then be linked and utilized by applications or higher-level components within the Android system, providing powerful functionalities while maintaining performance and efficiency.
Okay, that's so great. And I want to communicate between C++ service and my Java service, and that means I need to write in C++ I service. I need to write a library that we can use AIDL protocol to communicate between two layers, right?
To communicate between a C++ service and a Java service in Android, you typically use JNI, Java Native Interface. Here's how you can approach it. 1. Write the C++ service. Implement your C++ service that includes the functionality you need. This service will interact with the IEIDL protocol or any other protocol you're using for communication. 2. Expose native methods. In your C++ code, define native methods that Java can call. These methods act as bridges between your Java code and the C++ service. For example, you might define methods for initializing the service, sending receiving data via IEIDL protocol, etc. 3. Implement JNI wrapper. Write a JNI wrapper around your C++ code. This involves writing JNI functions that load and call your C++ native methods. JNI allows Java code to call functions written in C++. 4. Java interface. In your Java code, define an interface that declares the native methods you implemented in JNI. This allows your Java service or application to interact with the C++ service through the JNI layer. 5. Compile and link. Compile your C++ code into a shared library .so file that can be loaded by Android's runtime. Link this library with your JNI wrapper and include it in your Android project. 6. Integration. Finally, integrate the JNI wrapper and the Java interface into your Android application. You can then invoke the native methods from your Java code to communicate with the C++ service using the IEIDL protocol or other protocols as needed. This approach leverages JNI to bridge the gap between Java and C++ in Android, allowing seamless communication and integration of functionality across different layers of your application or system.
I'm curious about ZNI. Is that a the Java native interface? Is that right?
It seems there might be a misunderstanding here. The correct term is JNI, Java Native Interface, not ZNI. JNI stands for Java Native Interface, which is the standard way for Java code to call native methods written in languages like C or C++. JNI allows Java applications running on the Java Virtual Machine, JVM, to interact with native applications and libraries written in languages such as C or C++. It provides mechanisms to load and invoke native methods from Java code and to pass data between Java and native code. If you're working on Android and need to integrate native C++ functionality with Java code, JNI is the appropriate interface to use. It facilitates seamless communication and interaction between Java and native code, enabling developers to leverage the strengths of both languages in their applications.
So we have ZNI, and we also have AIDL. So what is the difference between two protocols, two type protocols?
It seems there might be some confusion. Let's clarify. 1. JNI Java Native Interface. JNI is not a protocol, but rather an interface that allows Java running the Java Virtual Machine, JVM, to call and be called by native applications and libraries written in languages like C or C++. It provides mechanisms for Java programs to interact with native code, including loading and invoking native methods, and passing data between Java and native code. 2. AIDL, Android Interface Definition Language. L is used in Android development to define interfaces that remote clients, such as other applications or services, can use to communicate with a service. It's a communication protocol that facilitates inter-process communication, IPC, between Android components, typically between activities, services, and other applications. To summarize, JNI Java Native Interface allows Java code to call native code, written in C or C++, and vice versa within the same process. AIDL, Android Interface Definition Language, defines interfaces for inter-process communication, IPC, between Android components, facilitating communication between different processes or applications on an Android device. They serve different purposes. JNI for integrating native code with Java in the same process, and AIDL for defining interfaces between components across different processes on Android.
So is AIDL is a protocol in IPC in Android.
It seems there might be a misunderstanding or a typo. There is no widely recognized acronym EIDL related to IPC, inter-process communication, in Android or general software development contexts. However, let's clarify the common IPC mechanisms used in Android. 1. Android Interface Definition Language. AIDL is used to define interfaces for communication between Android components running in different processes. It allows one Android component to invoke methods on another component, typically between applications or between an application and a system service. 2. Binder Framework. The Binder Framework is the underlying mechanism in Android for IPC. It manages the communication between different processes, facilitates remote method calls, and supports passing data between components efficiently. 3. Intent messaging. While not strictly IPC in the traditional sense, intents are used for asynchronous communication between Android components. They can trigger actions, start activities or services, and carry data between components within the same application or across different applications. These are the primary mechanisms used for IPC in Android development. If EIDL refers to something specific in your context, please provide more details so I can assist you accurately.
I want to know what is the AIDL, Android Interface Definition Language.
AIDL stands for Android Interface Definition Language, not Interpretation Definition Language. It is a language used in Android development to define interfaces for inter-process communication, IPC, between Android components. Here's a concise explanation. 1. Purpose. AIDL allows Android components, such as activities, services, and content providers, to communicate with each other across different processes. It defines the programming interface that clients can use to interact with a service. 2. Syntax. AIDL files .idl define methods that can be called remotely, including the data types of their parameters and return values. These interfaces are then implemented in both the client and the service, ensuring that communication between them is well-defined and efficient. 3. Usage. AIDL is commonly used when developing Android services that need to be accessed by other applications or components. It helps abstract the complexities of IPC, ensuring that data can be passed between processes transparently and securely. In essence, AIDL facilitates structured and efficient communication between different parts of an Android application or between different applications running on the Android platform.
Okay, thank you. Now I have another question is, so what is the difference between interface and abstraction? Interface class and abstract class.
Sure. Let's clarify the difference between an interface and an abstract class in programming. 1. Interface. An interface in programming defines a contract of methods that a class must implement. It only includes method signatures without any implementation details. All methods in an interface are by default public and abstract, no method body. abstract class. An abstract class is a class that cannot be instantiated on its own. It exists solely to be inherited by other classes. It can contain both abstract, methods without implementation, and concrete methods, methods with implementation. Abstract classes can have member variables and constructors. A class can extend only one abstract class, single inheritance. Abstract classes are used when you want to define a blueprint for derived classes, but also want to provide some common functionality. In summary, an interface defines what a class can do, its behavior, without specifying how it does it, while an abstract class provides a partial implementation with some concrete methods and defines common behavior to be inherited by subclasses.
Okay, can you ask me a basic question about the knowledge in Java language, and I will answer. After that, you can correct me if I'm wrong. Please.
Sure. Here's a basic question about Java. What is the difference between array list and linked list in Java?
So I think the most difference between them is the array list is the the memory of each component in each position in the array is continuously, and so that means we can access every position in an array, and in the array linked list we cannot access to specific area. We have to go from the the first to the second and the third for and etc. And so that is the most different in the definition of them.
You're on the right track. Here's a clarification. One array list implemented as a resizable array. Elements are stored in contiguous memory locations, allowing fast random access using index. Good for scenarios where you frequently need to access elements by index. Slower for inserting or deleting elements in the middle of the list because it requires shifting elements. 2. Linked list, implemented as a doubly linked list. Elements are not stored in contiguous memory. Each element, node, contains a reference to the next and previous nodes. Good for scenarios where you frequently insert or delete elements in the middle of the list, as it requires adjusting only the adjacent nodes. Accessing elements requires traversing from the beginning of the list to the desired position, which can be slower for random access compared to array list. So while array list allows fast random access due to its contiguous memory layout, linked list is more efficient for frequent insertions and deletions in the middle of the list due to its structure. Each has its advantages depending on the specific use case in Java programming.
Okay, I know it. So can we move to the next question?
Sure, let's move on. What would you like to discuss or learn about next?
Uh, uh the same.
It seems like you might have accidentally sent a message with just "oh." Did you have another question or topic in mind? Feel free to let me know.
You just asked me a question about basic Java knowledge, and I will answer. And after that, you can correct me.
Certainly. Here's a basic Java question. What is the difference between coolpix and dot equals when comparing objects in Java?
Excuse me, can you repeat your question?
Don, soalnya saya tadi. Apa perbedaan understand equals apabila membandingkan objek di length?
What English, please? Do you speak English or the other language?
I apologize for any confusion earlier. Let me rephrase the question. What is the difference between using coolpix and dot equals when comparing objects in Java?
Kubit what?
It seems like there might have been a misunderstanding. Let's stick with discussing Java programming. Here's the question again. What is the difference between using quotes and dot equals when comparing objects in Java?
Yeah, I know your question about the object Java, but the other the
I think there might be some confusion. Let's focus on the Java question. In Java, what is the difference between using quotes and dot equals when comparing objects?
what is the oh here is the questions. In Java, what is the difference between using equal? That means equal equal and dot equal. Damn, it's hard to think about it. Makes me a lot of confusion. Okay, for this question, I think equal is they are compare the kind of address, right? Not compare the value. And when we use dot equal, and that is compare the value. So, for example, if you have two object kind of object like not for example it's integer a and integer b thì so if you use equal b that's incorrect and if you use integer not int that will return but 4. Okay, I will go for an example right here. We have Java like GDB, right? Now we have an two integer. If a equal b, here bring okay. And this is correct, right? And but when I change to integer and we need to import, right? How to import is Java last integer. I want to know about the Java last. Oh, it's still right. How about the string? A string, so a vector. This is a vector, an array, right? An array on object. I think this can be an object. Make array list. How to define arrays? Okay. Damn. you to compare primitive or check if two reference point to the same object equal. You compare the content or state of two objects. Okay, I think I create that string a primitive or check if to the same object for primitive data type. It compares the value for object reference. It compares the reference location memory address. Okay. Compare the value stored in two objects based on the implementation of the equal methods in object class. I don't know why was what is a kind of array list. I'm not good as go for Lycos and do a problem. Random, right? Random. Where's the random? This one. Too long. Okay. There are n project numbers from 0 to n minus 1. You are given an array milestone where each milestone A denotes the number of milestone the each project has. You can work on the project following these two rules. Every week you will finish exactly one milestone of one project. You must work every week, okay? You cannot work on two milestones from the same project for 2 consecutive weeks. Once on the milestone of all project are finished, or if only milestone that you can work will cause you to violate the approved rule, you will stop working. Note that you may not able to finish every project milestone due to 3 constraints. Return maximum value of which you would be able to work on project without violating the rules mentioned above. You have a list input. You have a list of milestone, right? It's a milestone, and the thing is, okay, for project 1 we have 1 milestone and 2, 3. Now we have rule. Every week you will finish exactly 1 milestone of one project. You must work every week. For example, about the maximum number of weeks you would be able to work on a project without violating the rule. Okay, that means we need to work as long as possible. We don't care about the finish. For example, during the first week you will work on project 0, and 2 you work in project 3, 2 and 2, 1, 3. That's actually that you need to complete this one. For example, right here we have this first, right? And then we go for this, and we go for this. The 1, 2, 3, 4, 5, 6, 7, right? It's 7. And okay, I think I understand the problem. How to solve it? How to solve it? I think I will think 5 minutes more. It's difficult, I think. 3 for example 3 is 1. Five, 5, 2, 1. That means we have pants. I'm thinking of like we has 5, right? The 5, right? And then 2 ones we have 2 and 1 right here. In total we have this element. And for example 1, 2, 3. And when we had 2, that's when 2 right here and 1 right here. Is that a good? It is good to start. For example, we can finish it. 2, 1, 2 with combination of the 2 and 1. If we have another project, that means 3. That means we can put 3 in them because it have more than space. It has a lot of space, like 1, 2, 3, 1, 2, 3, 4, 5, and 6. 6 space. And for example, we have another test case. No, we don't have any more test case. For the first thing I need to do is I will basically I will have put the mass value in here, and for example it's 7 and 3, 5 and 3, and we put 5 in here. That means how many left item? We have 4 space, and so space we can put 3 here. We have 1 space. We also put it right here. I'm done. I will solve it later. Goodbye. To summarize today, we just learn data preference, data, no English. We learn a lot about Java, right? We know about Android architecture. We know about how to communicate between Java native layer to the Java or application layer. That is the ZNI, and you AIDL. I already know about AIDL, but I have some confusion when I categorize this AIDL to the protocol. It's not a protocol. This is the language, because in AIDL we had L, right? L means language, so that's a language. Okay, thank you. Enough for today. Goodbye. And now I will play game with my friend.